Okay, video number 4 for proofs. This is for those of you that are doing Worksheet M and are stuck on the first problem. This one is a little bit different than what we worked through in class and a good thinking question. First, we're given that M is the midpoint of AB, so of course I wrote my given down, and we're trying to prove AM is 1/2 the length of AB. Now, I hope you can agree with that. If you look at your picture, that would always be true. For that matter, we could also say MB is half of AB, because the midpoint means that the two parts are equal. AM is equal to MB. Thus, both have to be half. Okay, but how do we actually get to that in a proof without using numbers and without just saying, well, it seems like it has to be true? I'm going to start by using my given information, midpoint, and I'm going to write down exactly what I just marked with tick marks. AM is equal to MB. We've been using complementary and supplementary. Don't forget, midpoint bisects. Those words imply things are equal, and we're just setting them equal to each other. Okay, so I use my given information. That's done. I only have one equation. I always need two equations. So now I need to come up with another equation. And if I don't have any more given information, it has to come from the picture. Looking at your picture, what can you get from your picture? Not a lot going on here. I don't have any angles to even talk about. I know you like to use vertical angles. They're not there. All I have is a segment. I already said the two parts are equal. The only other thing I can possibly think of is talking about AB, the entire length, and I can say that that whole is equal to the sum of the two parts, AM and MB. We like to say part plus part equals whole, officially called the segment addition postulate. So I use my given, I use my picture. I now have at least two equations. Let's see if we can work from there. Okay, I got to do something with the two equations. Put them together, simplify one of them somehow. And I'm seeing that I have an AM and an MB. And my proof statement doesn't have any MB in it. It's got the AM right here. It's got AB over here. So I've got AM here, I've got AB. I want to do something with this to get rid of it because that's not helping me. Somehow it's got to be gone by the time I get to my last statement, which better say this. So I'm going to see if I can replace MB with anything. And if I look at step 2, I'm told that AM is equal to MB, which means that instead of putting MB, I can actually put, you got it, AM in place of it. AM and MB are equal. That's what I'm told. I'm going to rewrite the rest of this. So I'm going to have AM plus AM is equal to AB. Looks a little different now because I actually have the same thing twice since I replaced MB with AM. Okay, hopefully you picked up on that substitution property whenever you're taking something out, putting something in place of it. Substitution. That one cannot be transitive if you're somebody that likes to do transitive instead of substitution, because I'm only replacing one thing, not the entire side of the equation. From here, it really becomes an algebra problem, and I know you're trying to get to the proof. We're in a better place here. Let's just think, how can we simplify this? Okay, if you're stuck, think of this as x plus x. And if you had x plus x equals anything, I don't care, what would you do with the two x's? Hopefully you'd say I've got 1x plus 1x giving me 2 x's. So I've got AM plus AM. In other words, I have one AM plus another AM. Altogether, I should be seeing that I have 2 of the length AM. Okay, some people like to put in parentheses just to sort of make it a little clearer. Equal to AB, I haven't changed the right side. Okay, be careful on your property here. This one's tricky. Okay, hopefully you're seeing that we did add. We added AM plus AM. However, the addition property of equality states that you must be adding to both sides of the equation. Did we change the right side in any way? Nope. We had AB, and we still have AB right here. Nothing changed. So, in order to justify this correctly, I have to say that I combined like terms is what we're looking for. Because that's a property that's only happening to one side of the equation. You're either adding or subtracting. again, goal is to simplify our equation. We've got 2am. I don't like 2am. I want to solve for am. Pretend that's your x, your variable. And if you go ahead and solve for am, to get rid of the 2, I have to use my division property. Divide by 2 on both sides, and that would leave me with am is equal to ab over 2, which is the same thing as saying 1/2 ab. And guess what? Without even looking at it, that is exactly what I was asked to prove. Am equals 1/2 ab. There it is. Congratulations. What you actually just did is you proved what we call in a more formal geometry class the midpoint theorem. A theorem being a true statement, something that you can prove, that's saying something different than the definition. In other words, the definition, go back to the beginning, was telling us that AM is equal to MB. This is telling us something different, but something that can be generated from things that we know to be true. So nice work. Keep going. Good luck with the rest of your proofs.